Okay, so our new topic is VPN. So VPN stands for Virtual Private Network. So virtually we are creating one network, that is virtual private network means virtually we are creating. So how we are creating and what is the requirement of VPN, so types of VPNs and how we'll configure the VPNs, and we'll discuss entire thing here step by step we'll discuss. So for VPN part, so before that, so what is VPN and how we will create the VPN and requirement. So if VPN is not there, so what is the problem? So before that, we'll discuss this thing, then we'll start VPN. So here we have it's our hub location. Can assume it's a hub location device. It means hub means your data center. You can assume like it's your data center, hub location. And we have a multiple spoke locations. One, two, three. These are the spoke locations. These are our spoke locations. Hub and spoke topology we are discussing now. This one spoke one and spoke two location, spoke two, branch two. Spoke means branches. These are the branches. Branch three and so branch three, and this one is a branch four. Different branches we have. So if we don't have the ISP internet, so how will communicate to each other? So we need to take some connectivity directly to our branches likewise. Then only we can able to reach. So it will be possible to make a lease we have to take a connectivity at branch to branch without ISP. It won't possible. It will not possible. So we need a ISP. So without ISP, we cannot able to reach. So ISP, it means we have a multiple ISPs. If you can assume, it's your Hyderabad location and hub location is Hyderabad and spoke locations are different locations, different geographical locations, means different countries. So direct connectivity we cannot able to establish in between. So directly means we have to give a connectivity through wire. So one geographical location to another geographical location, it is so costly. We cannot affordable also that much cost. So we need ISP. So in between multiple ISPs will possible. So now we are taking only one ISP in between. So ISP, it will be provide a connections, different connection they will provide to us. One is like leased line connection. It leased line connection will take first example is like leased line. It's a leased line connection. So leased line connection means they are providing one to one in between, no customers are available. So we are presently Wipro, you can assume like our company is ABC. ABC company, abc.com, our company name is abc.com. So they are, so Geo, you can take as an example as a ISP is a Geo, any different Airtel Bharat or BSNL, anything you can take. They are providing one connection, one point to another point. It's, we call it as a point to point, P to P, point to point. They are providing connection. So if they are providing only connection one location to another location, so here it is a more secure. So no customers are available. No one knows in between what we are using. So whichever protocols, whichever traffic, whichever entire thing. So our ABC users only know which traffic through pausing. So that is mostly in government sectors will use this kind of, those also defense are this kind of organizations will use mostly lease line kind of service, and it is so costly also. They are providing one-to-one reachability, point-to-point reachability. So it is so costly, even though this sir here will get less bandwidth also. Bandwidth is very less. Bandwidth is very less. Not much more bandwidth will get in these leisure line services. Apart from that, we have a MPLS service. MPLS, multi-protocol label switching. What it will be do? It will be provide not only one customer. This is our abc.com, our first branch 1, branch 2, branch 3, branch 4. Apart from that, MPLS, what it will be do? Here we have a XYZ client also. They have ISP guys have XYZ client also. This client to for this is the XYZ another branch. Branch to branch communication they provide. Who is responsible for this communication? ISP is the responsible to provide with the based on MPLS, multi-protocol label switching. The protocol, it will be add label, whichever the traffic is there, original traffic, it will be add on for that label. This is kind of label. This is entire IP addressing scheme available in this. It will be add one label and it will pass. That is, we call it as a multi-protocol label switching. So here our topic is not MPLS. So this is the kind of services ISPs are providing to us. So I don't want leased line service. I don't want MPLS service also. So even though compared to leased line, MPLS is less costly, not much more costly, because here we are getting the share media. So here we are getting share media. So we no need MPLS service also. So our branch is very small. Our company is very small. So we cannot affordable lease line service also. We cannot affordable MPLS also. So then what is the solution for us? Then what is the solution for us? We have a solution, VPN. So here we have a different types of VPNs. So now we'll move to how VPN will work. So that is the requirement how. So this is again our company ABC, you can assume, and we have a different branches. And in this time, I'm not taking any kind of MPLS or leased line service. And now I'm taking only simple internet, any internet service. You can assume any kind of internet service here. So it's kind of say again hub location, and these all are the branch locations, spoke locations. These are this is a spoke one, and this one is a spoke two, and this one is a spoke three. You can assume this is a different spokes. Spoke, it means up to spoke. It's a kind of branch. So now again communicator will connect to branch likewise. So what internet is providing now? So they are providing simple internet. So again, internet is not secure. So man in middle attack will be high. He will access our entire IP schemes. So it is not secure. So we need a solution. So we'll take here underlay service with the help of underlay service will take with the help of internet, and will create one VPN. Will create one VPN, virtual private network will create in between our one site to other site. Overlay. We are creating overlay. This is we call it as a site to site VPN. Site to site VPN will create. Will create one site to site VPN. So how it will be create? We have a different options for creating of site to site VPNs, not only for this only location. We'll create one more VPN. It's a point to point VPN with this branch to this branch and this up to this spoke location. We'll create. These all are the with tunnels. This is we call it as a VPN tunnel. This is we call it as a VPN, virtual private network tunnel. Will create tunnels. These are all are the tunnel. This it's overlay we're creating. Just we are taking services, reachability services, point to point. We are taking through internet only reachability. We are generating with the help of public IP addresses. Yesterday, what we discussed, NAT. Based on that, will taking with the help of public IP addresses. Here, they'll provide to us one public IP address. Here, any public IP address they provide. And here, they will provide to us one public IP address. So public IP to public IP address reachability will done. Then after then we have some LAN prefixes. Those are the our original traffic. That is the whichever this is the access switch, and access switch is connected to multiple users. We have a multiple users. These all are the users, and every user having their own. These users are connected like this, and these users are connected again core switch core device, and this is a different spoke location, and this here also we have the users, and here also we have the user, and here also we are having the user. This user wants to communicate for this user. So how he will be reached? Through overlay. With this tunnel he will reach, not this interfaces, not public IP addresses. They will reach. So this is the one of the packet originated. This is the public IP address. Entire thing will be happen. So here source is like over 10.1 and destination is like here 20.10. So for this IP scheme for source and destination and 20.1, and this is 20.1 and 20. So source and destination. So one label will be attached, and that it will be traffic move through this VPN, under this VPN again. Under this VPN, it will be safe and securely it will be read. And apart from that, we have a different protocols to configure it. We have a for VPN part, we have a different protocols. So here we have a GRE, Generic Routing Encapsulation. One more is IPSec VPN, IPSec VPN, and DMVPN, Dynamic Multi-Protocol Virtual Private Network, DMVPN. These are the protocols through which, through these types of VPN will, with the help of these technologies, will create the VPN. Through these technologies will create this kind of tunnels, this kind of secure tunnels, this kind of secure VPNs will create. So VPN is a private network create over public network for safe and secure communication. So these are the some we'll discuss these things. So VPN is a private network to create over a public network for a safe and secure communication. Yes. So this is the our public network. So based on this public network, we are creating overlay tunnel. That is, we call it as a VPN. So provides connection between two or more private network over public networks. So this is the our one of kind of LAN network, and this one is a LAN network. This is a LAN network. These all are the LAN networks. LAN to LAN communication will be happen with the help of VPNs. So it uses tunnel to allow remote user to access organization's private network. So this is a remote user. So this is kind of remote user. It's a different location and he wants to communicate our hub location. So in hub location only we have a servers. So this is kind of server. In this server we have a abc.com website. So he wants to access that website. So overlay he can access our organizations private networks. So you can access our private networks. So VPN uses network security protocols like IPSec, provide privacy and data integrity. So here it will provide security and data integrity. Whichever the traffic is originated, the traffic will be reached to exact destination location. That is data integrity. So it will be reach exact location, which our source is here 10.1 and destination is here different one. So if some other customer is connected here, so this is the XYZ connection, XYZ customer. So this is our ABC customer type. So for him, this is a two customer type. The data we originated for, this is our destination. The data cannot be delivered in this location. No, it won't deliver because we are creating the tunnel from this location to this location. So data integrity also it will be provided. So VPN provide more secure encapsulation, data integrity, entire thing will be provided. Who? So here we have a IPSec protocol. We'll discuss about it, more about it. But before that, we have a different types of protocols, that is GRE, IPSec, DM VPN. Based on this, we'll create VPNs. VPN service. Again, this is a site-to-site VPN. Again, we have a remote site VPN also. Remote site VPN also. So remote site means, for example, I'm working from home. This is my home. And I am working as a home. I want to reach my location, that is server is there. In this server, entire thing will be happening. So this is my organization website. So I want to reach privately. So here, remote to my home location, one tunnel will be created. This is the Wi-Fi. Again, in this Wi-Fi, I am accessing. So in here, I'm using Geo some router. So based on this Geo router, I can access the internet. So any router you can take, but it's a common internet I have taken. So based on this internet, I can reach. For that, I have to install in my laptop client VPN software, that it will be provide our client VPN software. I'll install in this my laptop and client VPN software. Based on that client VPN software, who will provide to us our organization wherever we are working. That organization is responsible to provide to us that client VPN software. Based on that software, I can reach from my site, my laptop to my organization's private networks. That is, we call it as a remote site VPN. So two types of VPNs we have mostly. One is site to site VPN, first one, and second one is remote site VPN. So for VPN configuration part, we have a three types of configuration part: GRE, IPSec, and DM VPN. Apart from that, we have a different VPN also, MPLS, L3 VPN also, and MPLS also. Those are the different technologies. Again, who will be install that? Those are the will config. If you are working in ISP, this is the ISP provider edge router, and this is the ISP provider edge router. So ISP having multiple routers. This is all are the ISP routers. These all are the not for the our individual brand routers. So those kind of services, though there will be used mostly those MPLS. So these are the technologies we'll discuss now one by one. So do you have any questions for up to here? The requirement and where we'll use, how we'll use.
No, Ali.
So these are types of VPNs. These are the types of VPNs, how we'll configure it. So to create virtual private network, we have a multiple options available. So in that laser line, GRE and DM VPN and MPLS L3 VPN and IPSec. So first we'll discuss what is a GRE. So GRE stands for Generic Routing Encapsulation.
Is that GRE or JGRE?
No, in the documentation, some mistake happened. It's a GRE, not a JGRE.
Okay.
So generic routing encapsulation, edit yourself. I'll provide next time. I'll change that. That is GRE. Yeah, I have also today only checked. It used to make communication possible between two different private network. It is a Cisco proprietary. And it used when packet need to be sent from one network to another network over the internet. Same thing we discussed. It used to have virtual point-to-point tunnel. So this is a point-to-point tunnel. So it's a point one. Can assume like this is a point one, and so this is a point two point tunnel. It will be established. So it will be not established point to multi-point. Point to multi-point means, so here it will be like, for example, uh, so this is a hub location and these all are the spoke locations. And in between internet is there. Point to multi-point. What is the point to multi-point? I am explaining. So point to multi-point means, again, tunnel will be established from here. This tunnel, only one tunnel. This is a multi-M point. So these all are the, again, connected like this. This is, we call it as a hub and spoke location. And actually, this is the hub and spoke location. And so only one hub and one point and one point to connected. But here you can assume like only one multi-point, it's connected entire branches. So here, if R1 wants to communicate, this is a branch one. This is a branch one wants to communicate to branch two. So directly he can reach here. If he want to communicate branch three, directly he can reach through internet. No need to go hub location. But in point to point location, if he want to communicate branch two, so here first he want to reach hub location, then he want to move branch location. This is a point to point location. So GRE support only point to point. If we have a multiple branch location, if we have 100 branches, so 100 tunnels we have to create. 100 tunnels we have to create here in point to point. But if we have a hub and spoke location, point to multi-point, it is dynamically, it will be created. No need to establish the 100 tunnels. So that is the main difference in between. Now move to the it is not a encrypted method. So the major drawback here, the disadvantage, this one, it is not use encryption. So whichever the data is there, point to point, it will be sent plain text. Everyone can read it. Everyone can open the packet, what is going inside, and he can easily read it and he can hack it also. He can trace something also. So that is the drawback. It is not to be encrypt method. Encryption will be not happen. GRE tunnel much easier to configure. It is much easier to configure. Drawbacks here. It work at point to point networks only. It is point to point network only. If we want multiple networks, yes, we have to create multiple point to point networks. Not here, we cannot do the multi-point networks. So there is no future to perform the encryption also. Encryption, that is what encryption performance is not happen. Need to configure multiple tunnels manually. We have to create multiple tunnels. That is what. These are the drawbacks. So one more for encryption part, for if we want to encrypt our data, so from point to point, and IPSec also one kind of point to point only. These also point to point network only. How many tunnels are there? So majorly in IPSec and GRE, though only one difference is there. It is a secure internet protocol security. Here it will be provide security. Here it is not provide. GRE will not provide the security. The major difference in between these two protocols. And here the whichever the data is there, point to point, it will be securely, it will be traveled. Securely it will be transferred with the based on the encryption method, and here it will be sent the encryption format, and it will be sent. Once it will be received, it will be decrypt the information and it will be sent to our LAN segments. We can easily communicate LAN. So whichever the tunnel is here created, that tunnel encrypted format it will be happen. So in IPSec, majorly we have a two phases, phase 1 and phase 2. We'll morely discuss in lab for those. Phase, what it will be, how we'll establish the phase 1 and how it will be established the phase 2. So some difficulty is there compared to comparison to GRE. So IPSec configuration is little bit tricky, a little bit tricky compared to GRE. So now move to the DMVPN, dynamic multi-point VPN, virtual private network. So DMVPN, here we have again three phases. First one is phase 1 and phase 2 and phase 3. In this phase 1, again point to point network only will create, and point to point. And here we have a multi-point GRE will use. Here we'll use only GRE again. In DMVPN again we'll use GRE. Here we will use in phase 2 we'll use multi-point GRE. Multi-point means we'll create M2 multi-point to 2-point network, hub to spoke locations, and here we'll use some encryptions and all. So that is all about the DMVPN. So again we have the MPLS-L3 VPN, which is the mostly internet service providers will use. In lab part, we'll discuss more. So do you have any questions in theoretical? Shall we move to the practical? If you have any questions, ask me. I'll stop the recording. Yeah.